مرحبا طلاب. I'll continue with the solving problems for chapter 4. We ended the last video with the question 4.29. I solved part A, which was for first order system. Now we take a second order system. Now he's saying this is this is the response of a second order system. Otherwise, when you go into these responses, you cannot tell if it's second or higher order system. So, okay, he's saying this is a second order system. I have the second order system response, and he's giving me the maximum value here. He's giving me the steady state value, and that's all. So let's start. So first, to find the transfer function, what do we need? We need to find zeta, omega n, and of course the gain. Now let's start. We have how to find the percent overshoot. We can see that it's that area. We say that C max, this is the value from here to here, of course. It's 13.82, so it's 13.82 minus the steady state value over steady state value, over steady state, EC steady state value times 100. So the C max is 13.8, of course, it's from here to here. This is the value, okay? So it's 13.82 minus, he's given me here that the steady state value is 11.03 divided by 11.03 times 100. From this, I calculated, multiply it by 100, I'll get the percent overshoot equal 25.3, of course, percent. So how do I get zeta? By using this expression. So use the percent overshoot a to minus zeta pi by 1 minus zeta square here, that one, okay? Always that one. So we get zeta equal 0.4. Now, what do I want to get? I want to get settling time. But how do I get settling time? We said we take a strip of value, وحدة equal 0.98 of the final value, which is 11.03, and the other one is 1.02 of the final value, so that I make the strip. هو الأوسيليشن إذا تلاحظ مدى يطلع لفوق جاي هنا لتحت، فهاي العشرة عندك الآن رسمتها، خل أنزل شوي. هاي العشرة اللي أنا رسمتها اللي هو 10. Let's say, what did I do? I calculated, I multiplied 11.03 times 0.98 times 0.98. So let's say you make a strip of 0.98 times 11.03, and it's equal 10.81. 10.81. Let's say that is that one. That one above the 10. This is the 10. It's very difficult from the figures, of course. If I want you to solve such a question, I have to put you everything, or the scale have to be very clear and very delicate. So 0.98, which we said is the 2% criteria, times 11.03, which is the final value or C steady state value, and I draw this line. When I see that this oscillation does not go out of this strip اللي هي 10.0831, and I can multiply 1.02, which is the one above the steady state value, times 11.03 and make the strip. So it's, let's say it's هنا دخلت بهاي الشريحة وبعد ما طلعت من عندها وراها, okay? So we measure here settling time. It's equal 2.62. I put it in red, right? So from here we have the settling time. Settling time equal 2.62 second, and settling time we know that is equal 4 by zeta omega n. Okay, zeta omega n. So we have zeta omega n times the settling time, which we have here, equal to 4. We get omega n from this expression. It's 3.82 rad على second. So we're going to write the transfer function, but there is one little thing that we have to think about. The transfer function راح equal في constant. هذا الكونستانت يحوي على omega n square فاحنا مرات نقول اتس اوميجا ان سكوير على هذا الاشي، بس مش دائما هو اوميجا ان سكوير على اوميجا ان سكوير. يمتى تحصل هاي الحاله؟ لما الستيدي ستيت فاليو من تعمل فاينل فاليو ثيورم يطلع لك يعني واحد، يعني يطلع لك يساوي لك الانبوت. يعني اذا حطيت 10 ستيب يطلع لك الاوتبوت 10، حطيت واحد يطلع لك واحد. بهالحاله يطلع لك اوميجا ان سكوير على اوميجا ان سكوير. بهالحاله اللي هي الستيدي ستيت فاليو لا يساوي لنا نفس من الفاينل فاليو ثيورم، اوكي؟ فلا يساوي لنا الستيب انبوت اللي هو بيحكي عنها انه هذا انه ستيب انبوت. فيعني انه راح نحط معناته هنا اتس كونستانت نحط ولازم نلقاها. وهذا طبعا حطينا هنا ايش هاي 2 زيتا اوميجا ان. عندي زيتا اوميجا ان من هنا طلعتها من السيتلينج تايم، فضربتها في 2 يطلع لي 2 زيتا اوميجا ان. واوميجا ان طلعتها هنا 3.82 ربعتها طلعت لي هنا اوميجا ان زد طلعت لي 14.5924 equal to C over R. So to get هاي الكي اللي أنا بتكلم عنها just to give you an idea، يعني it's not something difficult I hope. So نطلع ال steady state value from transfer function هاي سميتها واحد by final value theorem. فال steady state value راح تكون أنا حاطة step، فتروح الاس ويا القانون اللي أنا حطيته، فيبقى لك كي على أوميجا ان سكوير. فكي على أوميجا ان سكوير هذا يساوي لنا 11.03، لأن هذا الستدي ستيت فاليو. هو حاطط لي على الفيجر إنه الستدي ستيت فاليو equal 11.03، واضح؟ فهذا إذن كي على أوميجا ان سكوير يساوي لنا 11.03 from figure. معناها هاي كي كلها تساوي لنا 11.03 times أوميجا ان سكوير. simple as that، it's not something complicated. so طلعت هاي الكي طلعت لي 160.95، أحطها هنا وتطلع لي الترانسفير فانكشن. أوكي؟ of course إذا أنت تلقى solution manual أو whatever أو عندك يعني you can find the solution. Any question you have I am ready for you, and I consider this as typical questions that you can grasp and understand. Okay. If we go into question 444, you see that it's solution of state variable equation, and you are not asked to solve state variable equation. So, but only I'm going to use the expression, that one, which we given before in chapter 3. We can use it to find solution. So, what does he want? He's given me the state variable model of a system. Of course, we will take initial condition equal to 0. Okay? Initial condition equal to 0. Is it clear? Okay. Now solve for y of t. يريد هذا الاوتبوت. When u of t يساوي لنا step, we will use the transfer function formula of course, and I don't solve it for you if it's not يعني required by الخطة اللي أنا ندرس لك إياها إحنا شعبتين. بس هاي الطريقة ما فيهاش إشي، يعني إنه لأنه يريد الواي which is the output. So I'll get the transfer function y over u باستخدام هذا القانون. أوكي؟ هذا القانون. شوفوا القانون يقول y of s over u of s equal c si minus a inverse times b plus d. Of course d I don't have it. It doesn't give me d here. It's 0. And you remember that si minus a equal to it will be this is so si minus a will be s minus 1 s. Okay, this is si minus a. You can see that. So si minus a inverse راح تساوي لنا then تتذكرون for the second order for a matrix 2 by 2 you can apply the rule for inversing of a matrix. But here it will be that you change those which are the same, and those you change only the sign. So I change the sign, and they're the same, and I divide it by the determinant s times s squared minus 1. So it's minus and minus, so it will be plus 1. So now we write the transfer function y over u equal 3 by 2, which is given to me. This is C, and 1 over S squared plus 1, and this is Si minus A inverse, and times B, which is 0, 1, and I multiply this time this 0, plus this time this 1, so this is 1, this time this 0, plus S times 1 is S, so I have this. Then y of S equal U equal, now remember that U equal 1 over S, so I put 1 over S here. So y of S equal 3, 2. I left it as it is. Of course, I can bring this here. It's okay because it's a scalar quantity. For 3, 2 times 1 over S squared plus 1. And this one, it's the same, but I just put the step. Now what do? If I multiply this by this, it will be 3 times 1 plus 2 times S. So I have 1 over S, هاي S جبتها هنا, 1 over S في S square plus 1, and that one times that one. This 3 times 1 is 3 plus 2 times S, 2S. So I have the transfer function equal 3 plus 2S over S times S square plus 1. So what do? I'll separate them. Okay, I'll separate them. It's better. So you remember, if you go to هاي راح تختصر هاي مع هاي. So I'll have 2 على S square plus 1. This is easy. This is 2 times sine t, صح؟ لأنه هاي omega n is 1. So this is sine t. Okay. Here I can find it from the Laplace transform table actually. Where did we put it? There is one here. It's giving me 3 times 1 minus cosine t, also from the table. We can elaborate of this. This 2 over S squared plus 1, it's a sine and cosine. You remember those, you know those. So this one, the first one is number 10 from the table, that table which I'm talking about. This one is number higher. That one is omega, let's say omega square over S في S square plus that one, which is 25. So this is number 25, and this is number 10, as I said. So at the moment, I'll get the response. So if you get he want the response from a state variable, you just get the transfer function. Maybe we ask you find the transfer function first, then find the response. So this is easy, just a straightforward. It's only he's giving you the model in the state variable form. Okay. Also, if you go, I'll explain to you this. It's like a design. I solved for you one with spring and mass and damper as well. And we found J and K for the system, you remember? So it's a similar idea. I just to emphasize that this part of the system is to make a design. So he's given us that 1 point, it doesn't matter, a step, let's say of 1 given force to this system. I'll give it here. At t equal to 0. He's given the damping is equal to 1. And he wants to find K and M so that we have a settling time equal 8 and a peak time equal to 2 seconds. So it's a different requirement, let's say. So we have the transfer function. This is a typical transfer function. You have to remember always so that you can write it straightforward, okay? So it's x, which is the distance, divided by F, which is the force, equal 1 over ms squared plus fvs plus k. Divide by m, we said that get rid of this coefficient of s square, and it's a bit not because the pen is blue. So it's 1 over m s square plus fv over ms plus k m square. I just explained to you the procedure. So you have a settling time equal 4 over zeta omega n and is equal to 8. You can get zeta omega n from this expression. So we have this is half. So what do we have zeta omega n here? This is 2 zeta omega n. What's this? Omega n square. So you have zeta omega n equal to half. So 2 zeta omega n equal to 1. So I have fv over m equal to 1. And he's giving me fv equal to 1 as well. So I can get m. So this one is done. Now I have from Tp omega d Tp equal to here. I'll just maybe it's not clear. I hope you. Okay. Now we have given Tp is equal to second. Tp equal pi over omega d. I get omega d. So omega d equal pi over 2. Right? Now the characteristic equation here is equal s square, and we found this coefficient fv1. We found m equal to 1. This one. We found fv is given 1, and we find m equal to 1. So the coefficient here is equal to 1. So we have the characteristic equation, which is the denominator, is equal s square plus s plus k. So I only left k is missing to find. Right? So I'll find the roots. So it's minus half plus minus j half 1 minus 4k. And I carry on like that. So this one here, this is omega d. Okay? I have omega d equal pi over 2. You just have to solve. You square both sides of the equation, and you solve, and you find that k equal 2.217 equals, it's a Newton meter. Okay, so with this question, I think you will have a good background in the solving questions. Chapter is you see that this question is 70, so there is a lot of number. Maybe I'll give you a number of a question you can solve. I'll send it to you by an email. I hope this question solving is useful, and if you need anything, or if you want me to solve for you any question, I am ready for you. And I hope this question solution or solving it's useful, and hope to see you in the next video. Thank you. Bye bye.